Hello class, this video will review for test 3. Let's go to Pearson. The review has 45 questions. Question number 1. A popular brand of pen is available in 12 colors and 4 writing tips. How many different choices of pens do you have with this brand? Based on the fundamental counting principle, we are going to multiply the two numbers we have here. 12 times 4, 48. This task is to choose a brand. Choose a pen with the brand. 2 steps. The first step is to choose the color. 12 options. Second step is to choose the writing tips. 4 options. So we multiply 12 by 4. We have 48. Question number 2. An ice cream store sells 3 drinks in 4 sizes and 3 flavors. In how many ways can a customer order a drink? Same with earlier, this is an application of the fundamental counting principle. We are going to multiply all the 3 numbers. 3 times 4 times 3, 36. The task involved here is to order a drink. So first step is to choose one from the 3 drinks. Second step is to choose one from the 4 sizes. And the third step is to choose one from the 3 flavors. By the fundamental counting principle, we multiply the 3 numbers. We have the total number of ways to complete the whole task. 3 times 4, 12. 12 times 3, 36. Question number 3. In a different plan for area codes, the first digit could be any number from 2 through 5. The second digit was either 1 or 2. And the third digit could be any number except 6 or 8. With this plan, how many different area codes are possible? This is also an application of the fundamental counting principle. The task here is to create an area code. How many digits in this area codes? Based on the information that is given, we can tell there are 3 digits, right? 3 digits. The first digit must be from 2 through 5. How many options do we have to complete the first step? 2, 3, 4, 5. 4 different options, right? Yeah, so the first step, we have 4 options. 2, 3, 4, 5. The second digit was either 1 or 2. So to select a number for the second digit, we have 2 different options right here. And then multiply with the number of ways to complete the third step. The third step is to choose a digit for the third digit, right? The third digit could be any number except 6 or 8. It could be any number from 0 all the way to 9. Those are 10 digits, except 6 or 8. So we have 8 options. So 1, 2, 3, 4, 5, not 6, 7, not 8, 9, hold on. So we have 0, 1, 2, 3, 4, 5, and 7, 9. Yeah, 8 options. Multiply those 3 numbers together. Yeah, let me double check. 3, 4, 5, 3, 2, 3, 4, 5. That's 4. 4 times 2, and then times 8. 4 times 2 is 8. 8 times 8 is 64. This part is supposed to be on your scratch paper. I put it here, it's just for you to see. If I have a scratch paper, I would write on a scratch paper, right? But I want to demonstrate that to you. So make sure you only enter 64 in the cell when you submit the answer. Okay, so 64. Question number 4. License plates in a particular state display 2 letters followed by 2 numbers. How many different license plates can be manufactured for the state? So this task is to form a license plate. To form the license plate, we have 4 steps to follow. The first step is to choose a letter, put on the first slot, right? Yeah, the plate display 2 letters. The first letter could be any one of the 26 letters. The second letter also could be any one of the 26 letters, right? So that's the first 2 steps. Followed by 2 numbers. The first number could be any one of the 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 options here. And the second number also has 10 options here. Yeah, again, those are supposed to be on your scratch paper. You're not supposed to type them in the cell. Let's get our calculator. 2 letters followed by 2 numbers. So 2 letters, 26 times 26, and attach 2 zeros. Yeah, multiply by 10, multiply by 10, multiply by 100. So we have 67600. That many different license plates that can be manufactured for this state. This state doesn't have many cars from this. Yeah, license plates in a particular state display 2 letters followed by 2 numbers. 26 times 26, 676, 100. Okay. Next question. Question number 5. A club with 5 members is to choose 3 officers, president, vice president, and secretary-treasurer. If each office is to be held by 1 person and no person can hold more than 1 office, in how many ways can those offices be filled? This is a permutation problem. We choose 3 persons from the 5 members to fill in the 3 positions. The order of the 3 people matters because you take the vice president, I take the president. It's different from I'm the vice president, you are the president, right? So order play an important factor in this arrangement. So this is permutation. P35. Yeah, let me get my OneNote very quick. Knowing this is a permutation problem, you choose 3 people from the 5 members. So the total number of ways to do the problem. Give me 1 second. Let me center the notes. P35. Okay, P35. At this point, you should know how to compute P35. Get your calculator. Enter 5 first. And then go to Math. Go to Probability. And go down. Choose number 2, NPR. And enter 3. So P35 is 60. 60. That's correct. 5 times 4 times 3. 5 times 4, 20. 20 times 3 is 60. Okay, that's this question. Next question. Number 6. For a segment of a radio show, a disc jockey can play 5 records if there are 8 records to select from. So this is select 5 from 8. In how many ways can the program for this segment be arranged? The order matters in the arrangement. When it comes to performance, records, so if you are the manager in charge of arranging the segment, you concern the order, right? Firstly, you play what music. Secondly, you play what music. So this is a permutation. This is P58. Let me write it down. P58. Because you need to choose 5 records from the 8 available records and then make an ordered arrangement. So P58. Let's go to the calculator. TI-84 calculator. Enter 8. and then math, probability, number 2, NPR, and then enter 5, P58 equal to 6,720. 6,720, that many ways. Question number 7. At a benefit concert, 11 bands have volunteered to perform, but there's only enough time for 6. So your task or our task is to choose 6 from 11. How many lineups? Look at the keyword here. Lineups specifically tells us the order matters, right? Yeah, how many different lineups are possible? So this is a permutation. P 611, P611, P611. Let me double check. 11 bands volunteer, but only have 6 slots. So okay, very good. Let's work on the calculator. Enter 11 first, math, probability, NPR, and then enter 6. P11 6. This number is large. It's gonna be 332640. Double check. It never hurts. Always double check your answer, because you only have one attempt. If you mess up that one attempt, you lose the point on the test. This is 332,640. That many lineups. Type an integer or a fraction. So this is an integer, whole number. Question number 8. An election ballot asks voters to select 6 city commissioners from a group of 19. So choose 6 from 19 candidates. In how many ways can this be done? This is a combination problem. C619. C619. Why is combination not permutation anymore? Because the order of the 6 people that are going to be selected for to be the commissioners doesn't matter. It doesn't say president or vice president or any positions, right? Yeah, all it matters is to select a subgroup of size 6 from the total number 19 candidates. So it's a C619. Let me double check the number. Okay, very good. So let's go to the calculator, enter the bigger number first, 19, and then go to math, and then probability. This time we go down to choose number 3, NCR. So enter the number 6 now. We have 27,132. Let's enter the number right here. How many different ways we can get it done? We have 132. That many different ways to get it done. Next question. Number 9. In how many ways can a committee of 2 Democrats and 1 Republicans be formed from a group of 6 Democrats and 12 Republicans? Yeah, let me copy paste this question, and I'm going to explain by using fundamental counting principle. The task in this problem is to form the committee, right? But in order to complete the task, we need to follow 2 steps. First step is to get Republicans, Democrats. Second step is to get Republicans. All right? Yeah. So let's use the fundamental counting principle. We want to form a committee, but we want a committee has 2 Democrats. So you have to select the 2 Democrats from the 6 Democrats. That's the first step, right? And your committee want to have 1 Republican. Yeah, 2 Democrats, 1 Republican. Second step is you choose the one Republican from the 12 Republicans. Yeah, let me double check those numbers. Choose 2 Democrats from the 6 Democrats, and then select one only Republican from the 12 Republicans. Okay, so that's the solution. Yeah, let's find out what's the value. Let's do C62 first. Enter 6, math, probability, NCR, and enter 2. C62 or C26 is 15. 15 multiplied by 12. C112 is 12. So multiply by 12. We have 180. The answer is 180. 180. Okay, next question. Number 10. The Senate in a certain state is comprised of 56 Republicans, 40 Democrats, 4 independents. How many committees can be formed if each committee must have 3 Republicans and 2 Democrats? This question basically the same with earlier. Not exactly same. Same type of problem. Just different numbers. The task here is to form a committee, right? And the committee needs to have a certain number of Democrats and a certain number of Republicans. So the task also has 2 steps. This task also has 2 steps. So we're going to apply the fundamental counting principle. The first step, how many Republicans? We need 3 Republicans. We need 3 Republicans from how many Republicans? 56 Republicans. And then second step is we choose 2 Democrats from the 40 Democrats. Yeah, we are provided with multiple numbers here. So we need to be very careful. Yeah, the total number of Republicans are 56. We choose 3 from the 56 Republicans. And total number of Democrats are 40. So choose 2 from the 40. This problem has nothing to do with the independent at all. Okay, let's do the math. Let's do the calculation. Calculator 56, and then go to math, probability, NCR, and enter 3. And that number multiplied by, I use a parentheses, left-handed parentheses, and then 40. Go to math, probability, NCR, 2, close the parentheses. So we have a very large number here. Very large number here. Let me enter it here. 216. 216,000. So it is 21,621,600. 216,216,100. Let me double check the answer, okay, before we submit. So we have 3 Republicans from the 56 total Republicans. And we also have, we need 2 Democrats from the 40 Democrats. And multiply them together, we have a very large number, and that's the number we got, 216,216,100. Okay. Next question, number 10. The Senate, number 11. Number 11, solve by the method of your choice. 29 people purchase raffle tickets. 3 winning tickets are selected at random. If the first prize is $3,000, second prize is $2,500, and the third prize is $300, in how many different ways can the prize be awarded? This is a permutation problem because the order of the three people matters, because you get a 3,000, I get a 2,500 would be different from I got a 3,000, you get a 2,500, right? So this is definitely a permutation problem. The order matters. And we choose 3 from 29. So this is P329. 29 people purchase tickets. 3. In how many ways can the prizes be awarded? So P329. Okay, so we enter 29 first. Math, probability, NPR, 3. And the answer is 219, 24. 21,924. We have that many different ways in which the prizes can be awarded. All right, yeah, it's P329. P329. Next, in how many ways can a person order one ice cream cone with 3 different flavors of ice cream if there are 18 flavors to choose from, and it matters to the person how the 3 flavors are stacked on the cone? So that sentence tells us the order matters. It means the flavor is on the top, which flavor is on the top, which flavor on the middle, in the middle, which flavor is on the bottom. The order matters. So this is a permutation. Choose 3 from 18. Choose 3 from 18. So P318 or 18P3. Calculator. We enter 18 first, and then we go to math and NPR, and then enter 3. The answer is 4,896. 4,896. That many possible ways to order the ice cream cone. Question number 13. An ice cream parlor offers 29 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Different from the previous question. In this question, the order of the 3 flavors in a bowl does not matter. So this is a combination problem. Combination problem. So C329. Go to 29, go to calculator, enter 29, and then math, probability, NCR, 3. C29, 3. The answer is 3,654. Let's enter the answer. 3,654. Next question is about the probability. An 8-sided die is rolled. Find the probability of rolling an even number. The set of equally likely outcomes is shown below. So among the A number, how many of them are even? Half of them are even, right? 2, 4, 6, 8. So the probability is 1/2. Question number 15. And a 12-sided die is rolled. The set of equally likely outcomes is that. Find the probability of rolling a number less than 4. This is a theoretical probability model. Denominator would be the total number of possible outcomes in the sample space, that is 12. Numerator is the number of outcomes that favor the event, rolling a number less than 4. Less than 4, we have 1, 2, 3, so 3. 3 over 12, we have to simplify the fraction. Be very careful. For test 3, reading the information in the parentheses also very, very important. Let's see what do we have. After we simplify 3 over 12, we're gonna have 1 over 4. Question number 16. A fair coin. I'm just double checking everything's fine here. Question number 16. A fair coin is tossed 2 times in succession. The set of equally likely outcomes are given. So the sample space has 4 equally likely outcomes. This is a theoretical classical model. Find the probability of getting at least 1 head. Classical model, 2 numbers. One goes to the top, one goes to the bottom. The number goes on the bottom, going to be the total number of outcomes in the sample space, that is 4. Among the 4 outcomes, how many of them has at least 1 head? At least 1. Not is different from exactly 1. At least 1, including exactly 1 and exactly 2, because you only toss twice. So among the 4 outcomes, only 1 outcome has no head. All other 3, they have at least 1 head, so 3 over 4. Pretty straightforward. Getting at least 1 head is 3 over 4. Question number 17. You select a family with 3 children. If M represents male, F represents female, the set of equally likely outcomes for the children's genders is shown below. So this is a theoretical model. Find the probability of selecting a family with at least 1 female child. Similar with earlier, it's just that this time we have 8 outcomes in total in the sample space, because 2 times 2 times 2 is 8, right? Based on the fundamental counting principle. So we have 8 as the denominator. Among the 8 outcomes, how many of them favor the result, the event, at least 1 female? At least 1 female. When you look at all those outcomes, there's only the first one has no female, right? All other 7 outcomes at least has 1 female. Yeah, only the first outcome, MMM, all males. All other 7, they have at least 1 female. So the probability is 7 over 8. Question number 18. Jim, Don, Sarah, Simon, Eduardo, Maria, Larry, and Kim. So it's necessary for us to know how many people are there. So 1, 2, 3, 4, 5, 6, 7, 8. 8 people. Yeah, you should write it on your scratch paper, right? Yeah, 8 people here. 1, 2, 3, 4, 5, 6, 7, 8. Have all been invited to a dinner party. They arrive randomly and each person arrives at a different time. So completing the following 3 parts. Part 1, in how many ways can they arrive? The order of their arrivals matter, so it's a permutation. 8 people, P88, or 8 factorial. Let me double check one more time how many people over there. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So P factorial or P88. We enter 8. We enter 8 and then go to math, probability, and number 4 factorial. 8 factorial is a very large number. It is 40,000. 320, 40320. That many different ways they can arrive. Part B. In how many ways can Jim arrive first and Kim last? That's gonna be 6 factorial. Yeah, let me enter the answer first and I explain why. Okay. 6 factorial is 720. Let me explain why. This task for part B, the task is to make ordered arrangement such that Jim arrived first, Kim arrived last. So we have 8 time slots, right? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 time slots. So this is how we complete that task for that result. We arrange the first slot first. We only have one option. Put Jim there. And then we arrange the last slot. We only have one option. Put Kim there, right? And then how many slots do we have left? 6. We have 6 time slots. We have 6 people. And that is 6 factorial. 1 times 1 times 6 factorial by the fundamental counting principle. And 6 factorial is 720. That's the reason. Okay. And part C, find the probability that Jim will arrive first and Kim last. Type a fraction, simplify your answer. This question you should not feel unfamiliar because you should have seen this type of problem multiple times in your homework assignments. Yeah, very good design because part A gives you the denominator. Part B gives you the numerator, right? Yeah. So the rounding part, I give you a trick. Yeah, if you paid attention, your job is gonna be a lot easier in the test. You can use TI-84 calculator to simplify your fraction. So this is what we're gonna do. We're gonna enter 720 first, divided by 40,320. And we got a decimal. And then you go to math, fraction, and I got a 1/56. 1/56. By the way, this is not compromise your ability of simplifying a fraction manually. It's just one option that applying technology that make your job easier. You do have assignments need to complete to show me that you do understand what is a fraction. Let me get rid of that. Double check everything is fine. I'm not muted. I'm recording and I'm sharing. Okay, awesome. Let's continue. So it's 1/56. We can submit right now and go to next question. Question number 19. In one lottery, a player wins the jackpot by matching all 5 distinct numbers drawn in any order from the white balls 1 through 44 and matching the number on the gold ball 1 through 35. If one ticket is purchased, what is the probability of winning the jackpot? Let's take time to understand this problem. You see this problem in your assignment, homework assignments, right? None of them are strange. No surprise, to be honest, because the questions from the quizzes and the questions from the tests, they are from the same pool with the homework assignments questions. All you need to do is to pay attention, practice enough. It's not that we're trying to make questions very difficult and you've never seen it. You should have seen this multiple times. Okay, let's see. Let's figure out how do we play the game. My understanding is that it takes 2 steps to play the game. 2 steps. First step is you select 5 numbers from the 44 numbers. Okay, that is the white ball. So you have 44 white balls, right? And they are labeled as they are labeled as number 1 through number 44, and you are going to randomly select 5 from the 44 numbers to see how many of them matching. If all of them matching, then you are closer to get a jackpot. So by the way, no, since it says in any order, so that means the order doesn't matter. It's a combination, not a permutation. That's the first step. Second step is to choose one number. So we have one gold ball, right? The one gold ball could be labeled as any one from 1 through 35. It could be number 1, could be number 2, or could be number 35, right? Your task is to match the number. So choose one from the 35 numbers for the gold ball. That's the second step. All right, so you finish the 2 steps, you play the game. So that number is going to be our what denominator. That number is going to be our denominator. And the numerator, imagine numerator. How do we find the numerator? Numerator is we want to get a jackpot, right? Numerator. Okay. So imagine you have superpower. You know which 5 numbers are the winning numbers on the white ball, and you know which number is the winning number on the gold ball. So what you do is you select the 5 numbers exactly the same with the 5 winning numbers on the white ball, and then you select the 1 numbers from exactly the same with the winning number on the gold ball. That's the numerator, and that value is 1. So our probability is going to be 1 over C 44.5 times C 35.1. Okay, let's do the calculation. So the numerator is 1, so we don't have to simplify. A good news about this fraction is we don't have to simplify because numerator is 1, there's nothing to simplify. Denominator is going to be a large number. It makes sense, it's supposed to be a large number, right? Otherwise, everybody have very big chance to win jackpot and the business is going to go bankrupt. So let's see what the number is. We're going to type a simplified fraction. Numerator is 1. Denominator. Enter, go to calculator. Enter 44. And then math. Probability. NCR. 5. Yeah, that is a C544. It's already very large. And then multiply that number by 35. Yeah, multiply that number by 35. By 35. Okay, so the number is 38.3801 02 80. So it is 38 million 10,280. It makes sense, right? Many people, that every 38 million people, there's 1 person win a jackpot. 38010,280. Be very cautious about the number you enter. Next. Question number 20. The table shows the distribution by age of a random sample of 3,970 moviegoers ages 12 to 74. If one moviegoer is randomly selected from this population, find a probability expressed as a simplified fraction that the moviegoer's age is less than 64. Less than 64. We need to type a simplified fraction. Okay. This is empirical probability model. Empirical probability model. we have the population divided into age groups. How many people in total in the sample? 3970. That's going to be our denominator. Among those people, among those 3,970 people, how many of them is younger than 65? The last row, the last class or the group is older, equal to or older than 65, right? All other are younger. So what we can do is we can add those three numbers together. 1260 plus 740 plus 900. 1260 plus 740 plus 900. And the numerator is going to be 2900. And now I'm going to have to simplify this fraction. Use my calculator. Divide that number by 3,970. And I convert that decimal to a simplified fraction. I got a 290. Yeah, simply just remove the 0. 290 over 397. When I have extra time, I like to double check my answer by using a different method. I could firstly find the probability of select a person older, like equal or older 65-year-old. So that is 1070 divided by 3,970. And I subtract that from 1. Complement, remember that? And then convert that to fraction. Same answer, 290 over 397. Yeah. All right, next question. A single 6-sided die is rolled. Find the probability of rolling an even number or a number less than 3. So this is OR, right? We use addition rule. Addition rule has 2 formulas. Which formula to select, to apply, depends on are the 2 events mutually exclusive or not. So let's look at our 2 events. The first event, get an even number. Second event, get a number less than 3. Are the 2 events mutually exclusive or not? They are not mutually exclusive. It's possible for them to occur simultaneously because you roll a die, you get a number. The number could be even and at the same time less than 3. For example, 2, right? Okay. So this is how do we process, apply the addition rule when the 2 events are not mutually exclusive. Total number of outcomes in the sample space 6, no problem. So 6 on the bottom. Numerator, we're going to have 3 numbers, okay? Let's see among the 6 outcomes, how many of them favor the first event? How many of them are even number? 3 of them are even number, right? And put the 3 there and the plus. And among the 6 outcomes in total, how many of them favor the second event? Yeah, how many of them less than 3? 2 of them less than 3, right? Yeah, you have 6 numbers, 1, 2, 3, 4, 5, 6. 2 of them less than 3. So 1 and 2, so 2. So put it there. And minus, we're going to minus the number of the outcomes among the 6 outcomes that favor both events. Among the 6 outcomes, how many of them are even and less than 3? 1, right? How many of them are even, also less than 3? Only number 2. So there's only 1 number. So that's our numerator. Once you understand the addition rule, you can do this on a scratch paper, quickly get it done. Again, this is supposed to be on scratch paper. 3 plus 2 is 5, 5 minus 1 is 4. 4/6 reduce 2/3. Okay, yeah, let me double check. 4/6, 2/3. Yeah, don't forget, please erase that. Read the information in the parentheses. Type an integer with a fraction. Simplify your answer. Question number 22. The table shows the educational attainment of the population of a certain country, ages 25 and over, expressed in millions. Find the probability that a randomly selected person aged 25 and over has completed the 4 years of high school only or is a male. You know that is about the war. You know that is addition rule. And you also know the two events are not mutually exclusive. Which two events? First event, you randomly select a person and you get the person complete the 4-year high school only. So this category, 4-year high school only. That's the first event. Second event is male. Okay, male. So that's second event. They are not mutually exclusive. They could happen at the same time. The person who complete the 4-year high school only, of course, could be male, could be female, right? So not mutually exclusive. Same with earlier. In the numerator, we are going to have 3 numbers. Denominator is the total, 176 million. We do not have to worry about the million. For convenience, even million is not unit, we can see it as a unit. Okay, in the numerator, the first number is going to be the number of people who completed high school, 4-year high school only. 57. And the second number is going to be the total number of subjects in the sample who are male. 87. And then minus the number of the subjects who are both, who completed the 4-year high school only and male. So let's see the intersection of this column and the first row. So 29. Yeah, let me double check and make sure that I see those numbers clearly. 57 plus 87 minus 29, exactly. And then we are going to simplify this fraction. If the question asks you to do fraction and you enter decimal, you don't get a point. As simple as like that. So 57 plus 87 minus 29 divided by 176. Convert that to fraction and simplified. I got a 115. 115 over 176. 115 over 176. Yeah, let's erase those stuff. I suppose on your scratch paper. I repeatedly emphasizing that. So 115 over 176. Okay, next. A single die is rolled. Find the odds in favor of rolling a number greater than 2. In favor. Okay. So remember, odds is different from probability. Probability is a number. The number is a number between 0 and 1, bigger than or equal to 0, less than or equal to 1. It could be in the format of a decimal, also could be in the format of a fraction. But odds is a ratio. It involves 2 numbers. A ratio can be represented as a fraction. It doesn't mean it's a 1 fraction. It's just a way to express that ratio. So here, very clearly, they use the colon, right? First number to second number. The first number must be the probability of getting a number greater than 2. Okay, let's see what's the probability getting a number greater than 2. So it's die, so 6 outcomes in total. Among the 6 outcomes, how many of them greater than 2? 3, 4, 5, 6. Yeah, 4 of them greater than 2. And the second cell, you are going to enter the probability of not getting a number greater than 2. It's gonna be the complement of the first event, right? So use 1 to minus that. I keep the denominator 6. So 1 minus 4 over 6 is 2 over 6. But don't sum it. Please do not sum it. We need to simplify answers. We need to simplify your answers. 4 over 6 to 2 over 6. The denominator 6 cancel. And the 4 to 2 is actually 2 to 1. 2 to 1. That's the answer you're supposed to enter. All right? Yeah. Favor rolling a number greater than 2 is 2 to 1. Question number 24. A die is tossed or rolled. Find the odds against rolling a number greater than 2. This time is against the rolling number greater than 2, right? So the first cell is going to be the probability of not getting a number greater than 2. Second cell supposed to be the probability of getting a number greater than 2. Probability getting a number greater than 2 is 4 over 6. And the first cell is going to be the probability of the complement, not getting a number greater than 2. Then it's 1 and 2. So 2 over 6. And then we are going to simplify. Please simplify your answer. And we should have 1 to 2. 1 to 2. 1 to 2. Question number 25. What is the probability of obtaining 6 heads in a row when flipping a coin? So, okay. So our task here has 6 trials. Each trial is you flip a coin 1 time. So you do 6 of them, right? And all the 6 trials are independent with each other. You flip a coin 1 time and then another time, yeah, 6 times, yeah, altogether. So 6 trials. And we are looking for the probability of obtaining 6 heads for all the 6 trials. So since it's independent, we are going to apply multiplication rule. Use the first formula. When the probability, when the 2 events are independent, the probability of A and B would be probability of A times probability of B. So in this case, we can generalize the multiplication rule because we have 6 events, right? Yeah. So the probability of the first time we get a head, and the second time get a head, and the third time get a head, and the fourth time get a head, and the 5th time get a head, and the 6th time get a head equals the probability of the first time get a head. Yeah, you know, multiply all the other probabilities. So since the probability getting head is 1 over 2, we have 6 1/2 to multiply together. The probability is supposed to be 1/2 to the power of 6. 1 over 32, right? Hold on. 2 to the power of 6. 64. Yeah. 1/2 to the power of 6. 1 over 64. 64. 2 to the power of 6. 8 times 8, 64. Next. Elizabeth brought a box of donuts to share. There are 2 dozens, 24 donuts in a box, all identical in size, shape, and color. 6 are jelly-filled, 9 are lemon-filled, 9 are custard-filled. You randomly select 1 donut, eat it, and select another donut. find the probability of selecting a custard-filled donut followed by a jelly-filled donut. Okay. We are looking for probability of A and B, multiplication rule, but those two events are not independent. They are dependent. Yeah, we are looking for the probability the first time get a custard-filled and second time get a jelly-filled. Let's use the fundamental counting principle. It's actually technically not exactly fundamental counting principle, but we can use the fundamental counting principle to prove it. So since the task we have two steps, let's see the probability of the first step. The first step, we want what kind of result we want to achieve. The first time we want to get a custard-filled. So you have 24 donuts, right? Among the 24 donuts, how many of them are custard-filled? Custard-filled, 9 of them. So 9 here, right? Custard-filled, yeah. And then multiply by the probability of the second time you get a jelly-filled. Remember, they are not independent. Since the first time you ate a donut, you do not have 24 donuts left in the box anymore. You only have 23 left. And among the 23, how many of them are jelly-filled? 6. Yeah, that doesn't change because the first time you didn't get a jelly-filled. The first time you ate a custard-filled. So this probability is a conditional probability. It is the probability that the second time you get a jelly-filled flavor, given that the first time you get a custard-filled flavor. So the total number of donuts are 23. Among the 23 donuts, we have 6 of them are jelly-filled. Yeah, double check 6, 23, 24, custard-filled. Yeah, okay, very good. So let's calculate and simplify the result. That is 1, that is 4. So 9 over 92. Yeah, let me use the calculator to double check it. Double check the result. 9 divided by 24 multiplied by 6 divided by 23 and convert to fraction. 9 over 92, I was right, yeah. 9 over 92. Because this cancel become 1, so numerator is 9, and this become 4. 23 times 4 is 92. Yeah, don't forget, please erase those. Question number 27. An ice chest contains 6 cans of apple juice, 8 cans of grape juice, 4 cans of orange juice, and 2 cans of mango juice. Suppose that you reach into the container and randomly select 3 cans in succession. Find the probability of selecting a can of orange juice, then a can of grape juice, then a can of apple juice. Okay, how many steps here? 3 steps. By the fundamental counting principle or multiplication rule, we are going to have 3 probabilities multiplied all together for the result. And the first probability, the first time you get a orange juice. So how many cans in total? And you're going to write those numbers on your scratch paper. 6 apple. You have 6 apple, 8 grape, 4 orange, 2 mango. You have 20 in total, right? Yeah, let me double check. Especially when the numbers are written in words. 6 plus 8, 14. 14 plus 4, 18. 18 plus 2, 20. Yeah. So the first time you got a can of orange, among the 20 cans, how many of them are orange? 4. 4 cans are orange. So here's 4. And the second probability is going to be conditional. Suppose we're given the first time you already took a orange juice bottle and your chest only have 19 cans left. Among the 19 cans, you're gonna choose a grape juice. How many grape juice there? 8 cans of grape juice. 8. We have 8 here. And then the third fraction, probability also conditional. Given the first time you got a orange, second time you got a grape, and what's the probability of the third time you got a apple? So since you already took 2 cans, you only have 18 left. Among the 18 cans, oops, hold on. What happened? Yeah, among the 18 cans, how many of them are apple juice? Apple juice, 6. 6 of them. Right? So, and then you simplify and multiply them all together. Be very careful with the calculation. At the same time, let me double check. So you got a orange juice. It's 4 orange. And then grape. 8 grape. Yeah. And then apple. 6 apple. Okay. So that is 1/5. That is 1/3. So 1/15. So we have 8 here. 19 times 15. 285. 285. Yeah, how many orange left? If you already took 1 orange, you're right. Actually, you're right. If suppose we had one more step, but luckily we don't. We only have 3. Yeah, let me check the answer by using the calculator. 4 divided by 20 multiplied by 8 divided by 19 multiplied by 6 divided by 18. You know, when you work on a scratch paper, you should easier actually than for me to typing everything. We have 8/285. Yeah, correct. Don't forget to erase those. Yeah, I repeat that over and over, so please don't. I show those here because I want to demonstrate, right, for convenience. Next question. Question number 28. It's okay, Lane. Yeah, as my email says, you can watch the video later. Number 28. Express the following probability as a simplified fraction and as a decimal. If one person is selected from the population described in the table, find the probability that the person is married or has never married. Married is in this category. Never married is in this category, right? So obviously the 2 categories are mutually exclusive, right? Yeah, cannot happen at the same time. You married, then you are not never married. If you never married, then you are not married. So this is addition rule with mutually exclusive. So the probability of married or never married, the denominator is going to be the total number of people, 260. And the numerator, this time we are going to only have 2 numbers added together. First number, married, 132. Second number, never married, 81, plus 81. Let's simplify. 132 plus 81 divided by 260. And we simplify. We have 213. 213 over 260. And then express the probability as a decimal. Okay. We need to keep how many decimal places? 2 decimal places. So that's going to be 0.82. The calculator will really help you. 0.82. 0.82. 2 decimal places. Okay. Next. Question number 29. We are looking for the probability that the person is female or is divorced. Okay, this time the two events are not mutually exclusive. Total number of the people, 257 millions, right? Yeah, so that is the denominator. Numerator, this time we are going to have 3 numbers. The first number is the total number, is the number of the subjects who are female. How many female? 127. Second number is the number of people who are divorced. How many people divorced? 34. And then minus the third number. The third number is going to be the total number of people who are both. How many female divorced? Female. This column and second row, 19. Okay, let me double check. 257. 34, divorced and female. Female 127, 34 minus 19. Okay, so let's use a calculator to assist us. Numerator 127 plus 34 minus 19 divided by 257. And we'll convert that to fraction. 142 over 257. And erase those. Convert to decimal. Keep 2 decimal places. 0.55. Round it down. Awesome. I'm glad that Ashley and Lauren still here. So let's look at number 30. A construction company is planning to bid on a building contract. The bid costs the company $1,900. The probability that the bid is accepted is 1/4. If the bid is accepted, the company will make $17,600 minus the cost. We are looking for the expected value. Okay. With all other problems looking for expected values, all we need to do is to make a table, make a 4-column table. Make a 4-column table. Get the information. Okay. 4-column table. The first column, cases. I do not use outcomes because some of them are not outcomes outcome has a specific meaning in probability. And this is gonna be the profit, right? Profit. That's our random variable. And then the third column is gonna be the probability. Probability. And the last one is gonna be the product. How many cases do we have? We only have 2 cases. Either they accept the bid, right? Or not accept the bid. If the bid is accepted, the company make $17,600 minus the cost. So let's see how much is the profit. 17,600 minus 1,900. We have 157,000. And that probability is 1/4. And what's the profit if the bid is not accepted? Negative 1,900, right? Yeah, your cost will not recover. You just you lost the money. All right, so let me double check. That is 16 minus 150. Okay, so that probability would be 3 over 4. The probabilities in the column of probability always add up to 1. They are complement in this case. And then we are going to process, multiplying the profit with the corresponding probability for each row, for each case. And this one is 15700 over 4. And this one is negative. Let's see, what is 1,900 times 3? 5,700 over 4. And then we are going to add up the 2 probabilities and to have our expected value. All right, so we have 1, 2, 3, 4, 2,500. Yeah, because the denominator is 4, numerator 15700. So 3,700, you remove that, you have 10 grand. 10000 divided by 4, we have 2,500. 2,500. Let me double check the result. This is 137, 15,700 over 4. And that is negative 3,700 over 4. 10 grand divided by 4. Yeah, it's correct. 2,500. 2,500. 2,500. 2,500. That is the gain in the long run, right? In the long run, the construction company would expect to earn this amount of money on average per bid. Not much money. So 2,500. Okay. All right. So next. If you see me make any calculation mistake, please let me know. Question number 31. A game is played using 1 die. If the die is rolled and shows 2, player wins $25. If the die shows any number other than 2, the player wins nothing. Complete part A through part B. There's a very important information not included in the question above the horizontal line. And that piece of information is so important. If you miss it, you would get a problem wrong. What information? The game isn't free. There's a cost to play the game. All right, same with earlier, we are going to make a table. 1, 2, 3, 4, 2, 3. Cases. You get a number 2, and you didn't get a number 2, right? You roll a die. If you get a number 2, you win. Win how many dollars? Your profit. Yeah, you win $25, but you pay $5 to play it. So the cost is $5. So you win $20 only, right? Yeah, you win $25, but there's a cost $5, $20 profit. And the probability of winning is 1/6. Rolling a die, the probability getting number 2 is 1/6. And if you did not get a number 2 and you lose, you win nothing. It's not just you win nothing, you lose $5 because it costs $5 to play the game. And the probability is 5/6. And now let's do the product. 20 times 1/6, 20/6. Yeah, I do not rush to simplify yet. I want to keep them in the same denominator. And then -5 times 5/6, -25/6. And now we are going to add them all up. 20/6 plus -25/6. Yeah, we end up with a negative number, right? -5/6. That's your expected value. You're gonna expect to lose in the long run for each play. Round the nearest cent. Okay, don't forget it's a negative. 5/6, right? 5 divided by 6. We have 0.83. Round it down. Keep 2 decimal places. Nearest cent. 5 divided by 6. 0.83333. 0.83 negative. Okay. And the player expect to lose that much money. That's the value. That value represents the expected loss over the long run for each play. Okay, so a professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown in the following grouped frequency distribution. What is the class width? Yeah, a lot of information, but is a pretty straightforward, simple problem. What is the class width? Class width is the difference between any two adjacent lower limits. The first class lower limit is 15. The second class lower limit is 20. The difference is 5. By the way, it's not 4, okay? Please do not use 19 to minus 15 equals 4. That is very creative, but it is not the definition of class width. Class width, you go horizontal, is the distance between any two adjacent lower limits or upper limit, right? Yeah, 29 minus 24 is also 5. It's just a definition. You know it, you know it. You do know it, you do not know it, then you probably got it wrong. A professor, so this is the same problem background. We are looking for this time how many students were involved in the study. Okay. You know what? I need to ask a favor, Ashley or Lauren. So when you guys go to testing center, after you finish the test, can you email me back and tell me, were you able to use this feature or function when the lockdown browser is in place? So look at this here. If you remember, okay. How about I remind you later? Okay, thank you, Laura. You believe so? But it's a lockdown browser. If you can use this feature, then open in Excel. Let's see. The question is gonna be very easy. So you open that. If you manually, isn't that bad? You just add up all the frequencies. And then enable editing. So you see those frequencies, right? Yeah. We are going to add them up. So equals SUM from B2 to B. And this is annoying. This is my app. This stuff. So from B2 to B11. Double check. So that's the sum from B2 to B11 is 95. Yeah. Even we don't use that, we try to use a calculator. It's also doable. It's just very annoying. So let's do that. Clear everything. Let's add 9 with 14. With 14, this isn't too bad. Later we have questions pretty annoying. And 31 plus 19, 25, 27. Oh, okay, 85. Yeah, let them do it again. So 9 plus 14 plus 14 plus 13 plus 18 plus 11 plus that plus 8. 11 plus 8 and then plus 8 again. Oh, 95. It is 95. Okay. Next. So this time we are looking for the number of students had at least 40 social interactions for the week. At least 40. So that is bigger than or equal to 40. Bigger than or equal to 40. We're gonna add up to those 1, 2, 3, 4, the last 4 numbers together, okay? 13 of them. 13 of them. Among those people, how many of them at least have 40 social interactions? So 3 plus 6 is 9, plus 1 is 10, 10 plus 3 is 13. Okay. Yeah, I need if it's me, I really need the Excel to help me to finish this group frequency distribution table. Otherwise, my I don't have 100% accuracy. Okay, let's see. How do we use the Excel to process this problem? So when you open a file, you have the number given as a list, right? You see that? Yeah. And what we do is we are going to firstly sort it. We go to home and then go to sort from smallest to largest. And you see it's sorted already, right? It's sorted already. And then let's look at the question. The first class is 41 to 45. 41 to 45. I'm going to close this one. 41 to 45. I'm going to color it different. Color it in yellow. Yellow here, right? Yeah, 41 to 41 to 45. That's the first class. I'm going to color them differently for each class. The first class is 41 to 45. Second class is 46 to 50. 46 to 50. All right, so I'm going to color them differently. Color them blue or whatever the color is here. 46 to 50. And next class would be 51 to 55, right? 51 to 55. Do we have 51 to 55? We don't. It's a 0 actually, right? This class, 51 to 55, actually frequency is 0. We already know that. And 56 to 60. 56 to 60. Different color. You can still use yellow as long as they are not adjacent to each other. 56 to 60. And the next class, 61 to 65. 61 to 60. 61 to 65. Different color. And the next class, 66 to 70. 66 to 70. So all of them, the rest. Green. All right. So now we know that the first class, how many values fall in the first class? How many values in between 41 and 45? We need to just count this way. It's a lot easier, right? So we have 8 of them. 8 of them go fall in the first class, 41 to 54. Sorry, 45. 45. 41 to 45. So that is 8 of them. You can see there's 8 here, right? 8 of them. And the second class, 46 to 50. This color. How many of them? 14 minus 9. 14 minus 9 plus 1. So 14 minus 9 is 5 plus 1 is 6. So 1, 2, 3, 1, 2, 3. You can see it's 6, right? Well, actually, we use 14 to minus 8. That gives us 6. So the frequency of the second class is 6. And we already know the third class is 0. And the frequency for 56 to 60. So this is yellow. What do we have? 25 minus 14, 11. You can also count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. 11. So that's 11. And then 61 to 65. We use 37 to minus 25. That gives us 12. Yep, 12. Last class, the green one, 1, 2, 3, 1, 2, 3, 7. So 44 minus 37 is 7. You know, this is the only way I would like to do this kind of problem. And yeah, so how many numbers do we have in total? We should have 44 numbers in total, right? And 1, 2, 3, 4, 5, and that is 10, 15, 18, 36. 36, 40, 44, yeah. And those numbers are supposed to add up to 44. So that is 14, 25, 25 plus 12, 37, 37 plus 7, 44, yeah. Okay, so next question. We have a statement here about the graph. The graph is based on a sample of approximately 500 recent college graduates. Knowing this is a histogram, horizontal scale gives us different classes, and vertical scale are each class's frequencies. As you can see, this bar, the tallest bar, is already over 300, almost 350. And this yellow bar is around 300. So both of the two tallest bar over 1200, right? 600, yes, sorry, over 600. Over 600. So with the other bars, all other bars, of course, this go beyond, far go beyond 500. So false. The total number is larger. False, because the total number of data items is larger. How do we find the total number of data items? We add up those frequencies. Yeah, this is a 75 plus 150 plus 350 plus 300, and add up all those frequencies. As you can see, it's far more than just 500. Question number 27. This time we are determining if this statement true or false. It says more college graduates had starting salaries in the 61 grand to 64 grand range than in the 46 to 50 range. 61 to 65. 61 to 65 is this green. It says that has more people than 46 to 50, this yellow. That's false, because the bar is shorter. Because the bar for 61 to 65 is shorter than the bar for 46 to 50. So the frequency is lower, not bigger. Question number 38. For the stem leaf plot, I need help with Excel as well. So let's get Excel. Do the same thing with earlier. From the smallest to the largest. Let me close the one we already done. So choose the whole column and go to sort from the smallest to the largest. And it's sorted, right? You see that? Okay, very good. If you want to color it, is good. We need to enter the leaves, right? Yeah, let's see how many 20s do we have. We have 20. We have this many 20s. You want to color them? I like to color them, then I can see the better. So we're gonna have, oops. One, 4, 4, 6. The ones digit 1, 4, 4, 6. So we have a 1, no colon, okay, no comma. 1, 4, 4, 6. Yeah, 21, 22 24s, 1 26, 1 4 4 6, and then 30s. That's a lot. 0 1 3 3. Yeah, one at a time. 0 1 3 3. 0133 133 455 455 667 455 667. Yeah. Don't worry. Don't mind. Always double check. 01 01 2 threes 2 threes 1 4 2 5s 2 6 1 7. Okay. And for 4 days, all of them are 4 days. So we have 2 zeros, 2 ones, and we have 1 2 3 3 fours, 2 fives, 1 2 3 1 2, and then we have 1 6 6 7 8 9 9 6 7 8 9 9 6 7 8 9 9. Yeah, double check. 2 zeros, 2 ones, 3 fours, 2 zeros, 2 ones, 3 fours, 2 fives, 2 fives, 6 7 8 6 7 8, 2 nines. Very good. And then we're gonna do 50-ish. 0 0 1 2 6 9. 0 0 1 2 6 9. 0 0 1 2 6 9. Okay, last one. 0 1 3 6 9 9. Oops. Yeah, be very careful. Be very careful. 0 1 0 1 36 0 1 36 0 1 36 2 nines. Did I? Yeah, I have one extra 8. I did not erase it. 0 1 3 6 2 nines. 0 1 3 6 9 9. Okay, finally. So we're gonna answer the question based on the graph we got. What does the shape of the display reveal about the ages of the professors? 40-ish. The greatest number of college professors are in their 40s. This one is the longest, right? Those problems are not my favorite. Let me tell you. Okay, number 39. Find the mean of the following group of data items. So we're gonna add them up and divide by, or you can use Excel. Yeah, let's do the manually. So let's add 2 plus 4 plus 3 plus 6 plus 8 plus 1 plus 8 plus 9 equals, divided by how many items we have? 1 2 3 4 5 8. 5.125. 5.125. Just to play, you know, I'll use Excel to quickly get an answer. This time we use average. From A1 to A8. We have 8 numbers. Yeah, same thing. We got it right. Next question. 40. Find the mean again. Okay, let's do that. Let's add them all up and then divide by 5 this time. 115 plus 55 plus 85 plus 55 plus 75 divided by 5. 77. Double check. Close this one. Close this one. So always enter equal sign whenever you start a function. And pretty those function name are pretty just the same with consistent with the name. A1 to A5. Close the parentheses. Yeah, 77. Correct. Next. Find the median. Median is different, right? Okay. So give me 1 second. Let me copy paste the list of items on my note. You're going to do the same thing on your scratch paper. Because whenever we need to find a median, by the way, Excel still works. Excel still works, but we don't really need that. Actually, I prefer you use manually, then you understand the idea. You understand the concept. So we need to sort them from the smallest to the largest. Okay, start from the smallest is 3, and then 4, and then 5, and then 5, and then 6, and then 7, and then 9, and then 10. 1, 2, 3, 4, 5, 1, 2, 3. So 8 numbers. We have 8 numbers. So we're gonna find the median. Use this method. We have 2 numbers in the middle, right? Average them. Take the average of them. 5 plus 6 is 11. 5.5. Yeah, if we use the Excel, and enter equal median. We see that DIN, right? And then start from A1 to A8. $5.5. Same thing, right? Yeah, but I prefer you use this method, then you know the concept of median. Yeah, what is median? It's just the number right in the middle. If we have 2 numbers in the middle, then just take the average of the 2 numbers. 5.5. Next, question 42. Find the median again. Okay. You know, I can quickly get it done, this one. 65. Why is it 65? How many numbers do we have in total? 5 numbers in total, right? So we're going to remove the two smallest and remove the two largest. And you know 65 is right in the middle. And that's how I know. Question number 43. Find the mode. Yeah, mode is the value in the data set with the biggest frequency. So in the list, how do we have a number whose frequency is bigger than other numbers? I look at 34, 40, 44. They're all different, right? That means each data item has a frequency. Oh no, 52. My gosh. 52 has 2 with frequency. Okay. The mode is not 2, it's 52. There's only one mode. Double check. 52 and 34, 40, 44, 40. Yeah. 52 is the only mode. The frequency is 2. It's bigger than all other items. The mode is 52. This is to find the mid-range. What's the formula for mid-range? You add up the minimum and the maximum divided by 2. What's the minimum? 30. What's the maximum? 37. 37. Add them up and then divide by 2. Let's see what we have. 30 plus 37 divided by 2. We have 33.5. And let me double check one more time. 15, so 18.5. Smallest number is 30. Biggest number is 37. Yeah, that's correct. Don't forget to erase those. Next, what's this about? GPA, right? Last question. All right, so last question. Let's see what's the GPA of the student whose transcript for one semester probably is shown here. Make it bigger. Yeah, we're gonna make a table, all right? Firstly, we are going to assign the numbers to the letter. B is 3, 3, 3, C is 2. And then we are going to add one more column here to multiply the product, to multiply the credit with the corresponding number that is assigned to the grade of the class. So 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, 5 times 2 is 10. Okay, and then you are going to add up two things. You're going to add up those products. This is 21, 21, 31, 31, 46, and let me double check. This is 21 plus 25 is 46. 9, 12, 15, 10, so 25 plus 21, 46. And then we also need to add up those credits. 17. 5 plus 5 is 10, 10 plus 7 is 17. And then use the sum of those products divided by the sum of the credits. 46 divided by 17. 46 divided by 17. Let's see, what do we have? Round to the nearest hundredths, so keep 2 decimal places. 2.71. 2.71. Okay. All right, let's see. What do we get? Warning. We got them right. All right. All right, guys. Thank you guys for watching the video. And then please practice more. Let me stop the recording here.